All right, so we're going to uh go over the last section of the book today, or of the chapter. So basically this is precession, which is what happens when you have a spinning object uh but it's at an angle. So if it's at an angle, then mg, the weight of gravity, is no longer going to be uh equal to, or the weight of gravity is no longer going to be parallel to the uh angular momentum. Therefore, there is going to be some torque. And if you use the right hand rule, r cross p, or dl, torque equals r cross force equals dl dt. If you use the right hand rule, you'll find r. In this diagram, r is the little r pointing from the base of the top to the center of mass. R cross p is going to give you some torque pointing into the board, which means that instead of which means that the uh, angular the angular momentum is going to change. It's going to start moving around the center of the board, or it's going to start moving around in a circle around the uh, object, or around its initial, or around its the or sorry, I just lost my train of thought. So it means that angular momentum is going to move around rather than staying constant, and it's going to do something called precession, where you have this spinning pin, and then it starts moving as it's spinning round in a circle around a central axis, which is given by the direction of the force. So if this is the case, then torque is going to be equal to r mg sine theta, and then dl is going to be would equal to r mg sine theta dt, because the magnitude of the torque is equal to dl dt. So that tells us how dl is going to change, but DL isn't like a angular momentum isn't like a physical quantity. It's not something you can observe as easily as like mass, or times, or angle. So we want to put that in terms of angle. So if that's the case, then d phi is going to be, looking at the lower left-hand corner, d phi, the angle that it makes with respect to the z-axis, rather than the angle that it makes or the polar angle. If you remember calculus, I don't know if you've learned this or not, but it's the angle that you make on the xy plane as you're moving about in a circle. So this angle on the xy plane is going to be equal to dl divided by L sine theta, because L sine theta is the projection of L onto the XY plane. So d phi equals dl over L sine theta. dl is equal to rmg sine theta dt. So this is going to end up being equal to rmg over L dt. And then omega precession, the angular velocity of the precession. So how fast along it's spinning like this, rather than how fast it's spinning about its axis, is equal to d phi dt is equal to r mg over L, which is equal to r mg over I omega. because L is equal to I omega. So this might be a little confusing. I think it took me a while to get it as well. But if you have any questions, just reach out to me. I'm not sure that there's going to be any questions about this, but it is interesting that when you have a torque, when you have a force pulling down, because of the angular momentum, because of the angular momentum only responding to a torque, it causes it to move to the side and in a circle rather than moving down like you might expect. So the angular momentum keeps it from falling down like you would if you had just a non-spinning top there. And then this is basically just how tops work and gyroscopes. So hopefully that was all interesting. Hopefully it didn't overwhelm too much. I'll see you all on Monday.